Now, we talked about adding and subtracting. Now we're going to look at what happens if we multiply and divide. And it's a little bit different than adding and subtracting, so we'll have to go get into that. Multiplying and dividing are also opposite operations of each other. So multiplying is the opposite of dividing, and dividing is the opposite of multiplying. Therefore, to remove either, okay, so if we have something multiplying and we want to remove it, okay, we need to divide. If we have something dividing, we need to remove it, we need to multiply. The opposite, so if therefore to remove either, the opposite needs to be applied. Okay, so we need to apply the opposite if we want to remove a certain operation. Now remember, when we are talking about isolating variables, the important thing is to remove all the operations from that variable and get it all by itself. So in multiplying or dividing, to remove an operation, the operation needs to be applied to the entire side. Okay, not just one little thing. For the most part, we don't have to worry about that right now, but we need to apply it to the entire side. So if there's just a number, it's really easy, but if there's a whole operation, then it becomes a little bit more difficult. We won't get into that difficult part in this lesson here. We may get into that a little bit later on. Okay. So when we're taking a look at multiplying and dividing, the operation that needs to be removed will always be applied to the variable itself. So when removing it, the variable will now be by itself. And we use the term isolated. Okay, I use the term isolated. I know it kind of comes out of the box there, but I use the term isolated when I talk about it being by itself. We're wanting to isolate it, we're wanting to get it by itself. So let's solve for the unknown variable here. 5x equals 35. What this is telling us is it's 5 times x. Whatever value of x is, it's going to give us the value of 35. Now, the opposite operation to multiplying is dividing. Therefore, both sides need to be divided by the number that is being multiplied to x. So both of them need to be divided by 5 to get the variable by itself. Now, what does that look like? And again, I'm going to use kind of just a drawing tool here. 5 is being multiplied to x. So what we're going to do is we're going to take it and we're going to divide this side by 5. Now we're going to divide the entire thing, 5x by 5. If we multiply something by 5 and then divide it by 5, it's just going to give us the value itself. We can also think of it as a fraction and cancel out. 5 over 5 cancels out and becomes just 1. Okay, it becomes just 1. And we're going to now divide this one by 5 as well. So this is now 1x. It's not 0x, it's 1x. And that's important to understand because we still need an x there. It's still important to have that there. So then on the first side here, we have x now is all by itself because we have eliminated that 5. But on the other side, we still have to divide by 5. So we have 35 divided by 5, which in this case is 7. So it tells us that x has to be 7. 5 times 7 equals 35. And so that tells us that, in fact, it is true. Dividing is very similar to that, okay? Except dividing is the opposite of multiplying. The opposite operation of division is multiplication. Multiplication. Okay? So in other words, both sides need to be multiplied by whatever is being divided here. So if we're dividing by 8 and then we multiply that answer by 8, it cancels it out. It makes it even up. It makes it equal to the same thing. So in this case here, we need to multiply both sides by 8. So what it's telling us, okay, and now this, it's important again that we do to both sides, and I'm going to explain that in just with this here. Imagine that we do the entire thing, we times by 8. And that's supposed to be a times sign there. Okay, we multiply that side by 8, and then we also multiply this side by 8. Okay, so we multiply the entire thing by 8. So what we're doing now is we're doing x divided by 8 and then multiply by 8. So in fact, we eliminate it, okay? So in fact, it cancels out those 8s. And what we're going to be left with, let's get my equation here, is x is going to be left all by itself. 8 divided by 8 is just 1. So now it's just going to be actually x divided by 1, or x times 1, which doesn't change it. So it just keeps it as 8 as x. And then 9 times 8 is 72. And so we know that if we did 72 divided by 8, that would give us 9. Okay, 72 divided by 8 gives us 9. Take a look at a couple examples, and I'm just showing you a couple different ways that things might be written as well. Okay, 3x equals 18. So we divide by 3, divide this side by 3. That means this cancels out, and it means that x equals 6. So we cancel out that, x is left by itself, and 18 divided by 3 is 6. We can do the same thing here. You'll notice here we have like x times 12. Okay, it kind of switched around a little bit. Remember, multiplying doesn't matter. We can do 12x or x times 12. It doesn't really matter. But we're going to divide both sides by 12. Okay, this cancels out. It becomes 1. It doesn't actually become 0. It doesn't really cancel out, but it becomes 1. So we kind of get rid of it. And so we're just left with x here. We have to divide this side by 12 as well. And so what we're going to have left here is that x equals 84 divided by 12, and that is 7. Okay, so we're left with 7. Now, we might get some decimals in here. That's a possibility as well. For decimals, you can use a calculator, but you need to show what operations you've done. So you have to be showing it like this. You have to show which operations you've done to come up with your answer. Okay? Even if you use a calculator for it, you need to come up with the answer that way. And a lot of them you should be able to do without a calculator. Next one here, x divided by 4 equals 9. Well, we're going to want to times this side by 4, and that means that we also have to times this side by 4, or multiply by 4. These are going to cancel out, okay? And that's the beauty of it. It cancels out. We get rid of it. Okay? That's what we want to do. It becomes 1. So it doesn't actually become 0. It becomes 1. And so then this side will be just x. On this side here, we have 9 times 4, which is 36. So it tells us that 36 divided by 4 is equal to 9. 36 divided by 4 is equal to 9. Last one, wrote it out slightly different here. Okay, what we have is we have x over 6. It's in a fractional form. Okay, x over 6. It's still division. This is just x divided by 6, and we need to multiply by 6. And we need to multiply this side by 6 as well. So these are going to cancel out, and now we have a little bit of a bigger number, right? 42 times 6, okay? Which, yes, is bigger, but if we are able to use calculators, that's not too much of a problem. 42 times 6 is 252. So 252 divided by 6 equals 42. Okay? And that would be using a calculator to try to solve for our answers.